Hi, today we're going to do the notes for law of sines. So this falls in section 6.1 in your textbook, and it revolves around what we call oblique triangles. So if you remember from geometry, an oblique triangle is a triangle with no right angles. So if it doesn't have any right angles, then we can't use right triangle trig, which we've been studying in units 4 and 5. So this is what we do when that case happens. We use our trig laws. And those trig laws revolve around given information in a triangle, we have to classify it, and then we can determine which trig law will apply. So as you can see in law of sines, if you have triangle ABC where A, B, and C are angles, and we have sides lowercase ABC, which are again the sides, then these ratios are true. So sine A over A is equal to sine B over B is equal to sine C over C. And because of these two equal signs right here, then I can use these two ratios and say sine A over A equals sine B over B, solve that proportion and get an answer. Or I could use these two ratios, sine B over B equals sine C over C, solve the proportion and get an answer. Or because we know the property that lets us look when we have multiple things, and we can say sine A over A equals sine C over C. Solve that proportion, and that could be true. The reciprocals, the inverses, are true as well. So you could have the sides on top and the angles on bottom. And the only reason we might use one over the other is sometimes it's a little easier to isolate what you need when it's in one form over the other. But you can get there with either one. So these are the angles or the triangles that I'm talking about. I'm talking about one that has 3 acute angles, where there's no right angle. And if we were doing right triangle trig, then we'd probably drop this line down here, and now we have right angles, so then we could find the area of this triangle, and then we find the area of this triangle, and then we add it together to get the area of the whole triangle. You know, those are the kind of things that we did with triangles, right? And then we'll also be talking about this triangle right here, where it has this one obtuse angle. And so oblique triangles will either have 3 acute angles or 1 obtuse angle and 2 acute angles. And so those are the two situations that we would use when we're dealing with trig laws. So a few things. Again, we use law of sines when we don't have a right angle. And if you're given, look, the acronyms are coming back from geometry, right? Angle, side, angle, 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 side, and side, side, angle. And we will call it side, side, angle, not the reverse. Information given, so you've labeled your triangle, you've identified all your given information, you've identified which one of these 3 it is, and then you would proceed to using your law of sines. When we're looking at these particular classifications, this is only going to ever produce 1, this is only going to ever produce 2. This one can give us a little bit of trouble, side, side, angle. And if you have a side, side, angle situation, that's what we call the ambiguous case. And what that means is we could have a triangle that when we label all the sides, it doesn't work. We could have 0 solutions. For instance, maybe we have this length and we have this length. The length of side A stops right here and doesn't actually close in the triangle. That would be a situation where there's no solutions. If you can find 1 solution, then you will check to see if you can find a second solution, because there can be 2 ways a triangle could work out. It could work out as an acute angle here, or it could work out with the obtuse angle over here. So you have to check for that. If you lay out your given information and you have a side, 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 or a side, angle, side, then that's what we'll be doing in the next lesson when we learn law of cosines. It's really important to learn law of sines and know it well, though, because even if we're doing something that begins out as a law of cosines problem, at some point you might be able to switch and use law of sines, which is super easy to solve for, because remember, you're just solving a proportion. So again, we'll cover law of cosines next time, but I just wanted you to think about that. So the process that we're going to use is, let's see, I see a typo right there. That should be side, side, angle. Okay, sorry about that. You draw your triangle, you label your given information, you decide which type of triangle you're given, side, angle, side, 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 angle, side, angle, 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 side, or side, side, angle. And then if you have the angle, side, angle, the angle, angle, side, or the side, side, angle, then solve the triangle with the law of sines. If you have side, side, angle, remember that's the ambiguous case, so you need to check. If you have a solution, then you need to double check that you have 2. Okay, you don't have 2, excuse me. When you solve for angle or side, set up your answer so that it can go directly in the calculator. Be really careful to watch out for equal signs and approximately signs. And then I would expect this statement on your paper where you are actually, where I have isolated B, if that's what I'm solving for, and this is what I'm putting in my calculator. No rounding until the final answer. This is one way to avoid that mistake, because if you round before the final answer, you will lose points on your answers because you are specifically told to only round your final answer in that one step. So if you get in the habit of doing this, not to mention this is what I'm looking for on your paper, it'll just keep you from having that error. Okay, then the other thing we're going to talk about is finding the area of an oblique triangle. Remember, we don't have a right angle, so we can't use 1/2 times the base times the height, because that's right triangle trig. So we have some new area formulas, and there are actually 3 of them, but really you just need to know the pattern of them. So if you're given a triangle and you have 2 sides, and then you have the angle of the missing side. So you take 1/2 the 2 sides times the sine of the angle for the side you don't have. So like here you had sine A and B, so we took the sine of C. Here we have sides A and C, so we took the sine of B. Here we have the sides B and C, so we took the sine of A, and then you just multiply it by 1/2. So it's not a hard formula to remember, and I just wanted you to understand that it's really not 3 formulas that you need to learn. It's just that you need to learn the pattern, and we know we're going to use this when we have at least 2 sides and an angle to find the area of the oblique triangle. All right, so today we're going to work through these problems. In problems 1, we're going to round A, B, C, and D to the nearest hundredth. 2 and 3 will round to the thousandths, just like normal. We do have to talk about how to handle this. We're going to look at some features on your calculator in the angle menu, so be sure you have your calculator handy. And now we'll work through the problems. Okay, on the first problem, 1A, we have triangle ABC. We're solving for the missing sides and angles, and when we're solving a triangle, that's what we mean. We find all of the missing sides and angles. Sometimes it'll just say find a certain angle or find a certain side, and if that's what the directions tell you to do, be sure and do that. You don't want to waste time solving for things you don't need to be solving for. So in this case, we're given 2 angles and a side. So we have angle C, which is 102.3 degrees, angle B, which is 28.7 degrees, and side C, which is approximately 27.4 feet. So first thing, you want to make sure your calculator is set on degrees because we're doing triangles. So all of those measurements will be in degrees. And if you don't remember how to do that, one more time, then you go to the mode button and you go down to, it should be preset to be on radians if you've done any kind of clear on it. So you just want to arrow over to degree and make sure you have that working for the problem. All right, so then we're going to draw our triangle, and I can see right away there's an obtuse angle there, an angle bigger than 90 degrees. So I'm going to draw it right here. And so what I did is I drew in my notes here everything that's in a dark color is the given information. So we have angle C and we have angle B. That leaves this to be angle A. We have side B, which is across from angle B, so that's right there. So what I don't know is A, side C, and side A. So those are the 3 things I need to find to be able to solve. Before I do anything, I want to classify this. So I have an angle and a side. So it's angle, angle, side, which means I don't have to worry about the ambiguous case. I can just solve my triangle. All right. So first we're going to find A, and to find A we're going to take 180 degrees. We're going to subtract the 2 given angles, and that tells us that angle A is 49 degrees. So I found one of my 3 things that I'm looking for. And then 2, to find the side, I'm going to use law of sines. So I'm going to take, and you don't have to write it down. You can write it down if it makes you feel better or more comfortable, to say sine of A over A equals sine of B over B. If you can go straight to putting your information in the law of sines, I'm okay with that. You can always check with your teacher in case she wants something different. So I have sine of 49 degrees, which would be A over little a, which is what I'm trying to find. And I have sine of 28.7 degrees, which is B, over length B, which is 27.4. So I want to get A by itself. So we know when we solve a proportion, we would multiply these two things together and then divide by the third thing, the one that's across from what you're trying to solve for. So we're going to put this in our calculator. We're going to be in degrees. We're going to go to our home screen. We're going to get a fraction from the fraction menu, and we're going to do 27.4 sine of 49 degrees all over sine of 28.7. And so we're putting that in one step. You can see where I have it written on my paper. When I execute it, it tells me it's 43 point, and that looks like should be 0.6. Okay, and remember we said we were going to the hundredths, and we remember to put our units on there. Okay, so that's finding angle A and side A. So now we need to find side C. So I'm going to use sine C over C, and then sine B, because that's given information. So again, just a couple of reminders on the note page. Enter it into your calculator, make sure you're in degree mode, use the fraction template, store values if you need to or are going to use them in the problem later, and you can always put quote marks around them if you're going to need to do that, especially like cases where there's maybe multiple angles. All right, so sine of B over B, sine of C over C. To solve for C, we multiply these two together and divide by this. So I set up my equation, and then I go straight into my calculator. I know I'm in degree mode, and I come up with 55.75 feet. And so if it asks for you to write out your answers, then you would say angle A is 49 degrees, side A is approximately, with squiggles, 43.06, and side C is approximately 55.75 feet. So it may be on a test question that it may ask you for one of those three things, so you kind of want to pay attention to what you're doing so you don't do extra work, but we're just going to practice solving everything in the notes. Okay, so for problem 1B, we're going to solve triangle ABC. We're given A is 22 inches, little b is 12 inches, and angle A is 42 inches. So we're given a side, and an angle. So remember, we're going to draw our triangle, we're going to label it. Since I don't see an obtuse angle, then I'm going to go ahead and draw it as three acute angles. I'm going to classify it. Remember, the stuff in black is given, so I have side, angle, which means I have the possibility of 0, 1, or 2 solutions. If you get in the habit of doing that first, you're not likely to forget to find the second solution, which is definitely a common mistake. So the stuff in orange, little c, big B, and big C are the things that we are solving for. Okay, remember we're finding it to the nearest thousandth. So let's start with finding B. Okay, so when I find angle B, this time I did it the other way so you could see it works both ways. So I did little b over sine B, little a over sine A, solve my proportion. And I was looking for sine B, so I multiplied these two together and divided by 22. Okay, we don't know what sine B is, that's the unknown. We do know the length of B, the length of A, and we can calculate sine of 42. So to isolate sine of B, I multiplied 12 by sine 42 over 22, and then I solved that. And remember, to find B, we use the arc symbols on the calculator to find B, and then if we want to store B, we can put that in any of the letters, but I would put it in B since that's what we're doing. Okay, so when we get to this point, we know we have this fraction. We're putting it in directly, so we're not risking any early rounding errors. We get 21.41 degrees. So we need to check to see if there's a second solution. Okay, so the first thing we do is we know that sine of 21.41 is in the first quadrant. We know that sine is positive also in the second quadrant. So then we find the angle in the second quadrant by doing 180 minus the reference angle, which is this angle right here. And we get this angle to be 158.59. Now remember, we're talking about that being the angle that goes from here to here. So I need to check to see if I have a second triangle. And I do that by using this second angle, which is 158.59. I'm going to add it to the angle that's given in the problem, and I'm going to check to see is there enough to form a third angle in the triangle and not go over 180 degrees. So if I do 42 plus 158.59, I get 259 degrees. That means with just these two angles alone, we've already exceeded the allotted amount of space for a triangle, right? Because all three angles have to add up to be 180 degrees. So since this number is bigger than 180 degrees, there's no room left to fit in a third angle. So only one solution is going to exist. That means we don't have to worry about this. We're only going to solve our triangle using this angle. Okay? So remember, we need to find angle C and angle B. So to find angle C, I take 180 degrees, I subtract angle A, which was this one in the problem right here. And then I subtract angle B, which is this one in the first quadrant that we just calculated. So that's why I went ahead and stored it at this point. So I had that there. So I can do 180 minus 42 minus B, and that gives me approximately 116.59 degrees. Okay, so then to find side C, we use our law of sines. So we're going to do, I did sine A over length A, sine C over length C, because I'm trying to find C. I isolate C, so I'm multiplying these two together, dividing by that, putting it directly in my calculator, and I get 29.40 inches. Don't forget your units. Don't forget your squiggle. Alright, so we found B up here, we found C down here, we found little c right here. So we have solved our triangle. We have these pieces of information, and we only have one solution exist because of our check right here, where that gave us a degree that was way bigger than 180 degrees. Okay, in problem 1C, again, solving triangle ABC, given A is 15 feet, B is 25 feet, and angle A is 85 degrees. So we have two sides and an angle, so we're going to lay out our triangle and check to see what kind of triangle we have. So I have two lengths and I have a side, so I have in order side, then a side, then an angle. So that means I have the possibility of 0, 1, or 2. So first I'm checking to see if I have a solution at all, and then if I have a solution at all, then I'm checking to see if there's a second one. So to solve this, I need to find the missing angles C and B and the side C. So first thing we're going to do is find angle B. So I have sine of A over A, sine of B over B. Remember, you can go straight to here. I just wanted to keep track of where we were for our notes. So we have sine of the given A over 15, which is a given length, sine of B, which we don't know, over the given length of 25. So to get sine of B by itself, we multiply these two together, divide by 15. And then to get the angle, because right now we're saying what angle has a sine value that equals this. And so I do the arc sine. I'm not restricting it or anything. I'm just using that tool on the calculator to be able to find the angle. And right now, if I simplify this out, I get 1.660. Hopefully you see the problem with that, because if you remember your graph for sine, right? We have starts at 0, it's 1 at pi over 2, 0 at pi, -1 at 3 pi over 2, and 0 at 2 pi. But I'm asking for what angle has a sine value of 1.66. If as high as it gets is 1, how could I ever get above it and find a value for 1.66? I can't. And because the 1.66 is greater than 1, this can never happen. So in essence, that means there is no solution. And remember, anytime you write down no solution as an answer, I will be expecting for you to justify why. In this case, I said no solution exists for this triangle. The triangle will not form with the given information. Or you could have said no solution, sine of B is approximately 1.660, which can never happen, or is greater than 1. So there's lots of ways you can justify or explain it. but it should be a coherent thought, not just a bunch of numbers rambling written down as justification. So that's just good practice for our calculus exam next year. All right, so this is an example of a side, side, side where no solution is possible, and what that probably means is length C didn't get long enough to close in the gap somewhere. So you had like a gap in the triangle, which is why you have no solution. Okay, for problem 1D, again we have our triangle ABD with our given sides, and the given information is A equals 12 meters, B equals 31 meters, and angle A is 20.5. So we are given two sides and an angle. So we're going to label our triangle. It's always a good idea to do that at the beginning, kind of figure out what it is you're needing to do. And so I have a side of 12, a side of 31, and then an angle. So we have a side-side angle situation. Remember, that can result in 0 solutions like what happened a moment ago, 1 solution or 2 solutions. And when we solve the triangle, that means we need to find the missing angles B and C and side C. Okay, so let's start just like I normally would. I'm going to find my angle B, and that's just an acute angle. So I did A and A and B and B, so that leaves my unknown to be B, and I did that because I wanted to use given information to avoid rounding errors. So I have sine of B over 31, sine of A, which is 20.5 over 12. So I'm solving for sine of B, so I'm going to multiply these two together and divide by 12. So that's what it should look like on my paper. Sine of B is 0.9047. So we know that that should be okay because that's a ratio that could fit on our graph. So I calculated it using ARC and I stored my B value. So the B angle ends up being approximately 64.78 degrees. All right, so now that we have a B, we need to check to see if that angle could be obtuse or if that angle could be acute. And so I do that. Just like we did on previous problems. So I'm going to say I know that this is a positive ratio, so sine can be positive here and here. I just calculated what it was in the first quadrant, so remember in the second quadrant it would be from here to here. So I do 180 minus the reference angle that's in the first quadrant, and that gives me an angle of 115.20 degrees. So now I check to see if I can have 1 or 2 solutions, because this tells me for certain I have 1 solution. This is how I check to see if I have a second. So I take the 115.2, which I just calculated in quadrant 2. I add the 20.5, which was angle A in the given information, together, and I get 135.7 degrees. Since 135.7 degrees is less than 180, we know that a second triangle exists. All right, so we need to find them both, and we need to keep the parts of each triangle together with the other. So what I tend to do is I write down triangle number 1, triangle number 2, write down what I need to find in each triangle and make myself a little chart before I start. That helps me keep from confusing the information together. So this is what I mean by the two possibilities. So if the angle B was 64.78 degrees, it looks like this kind of triangle. If this 12 meters had swung in here, then the length of CB would be right here, and it would still be 12. So this side would be 12 meters if it were acute. This side is also 12 meters, but this angle is obtuse, and that's that second angle right there. So now we're going to complete the triangle, each triangle. So we know that angle B here is 64.78. We know here it's 115.20. Then we're going to calculate C. So we do 180 minus the angle we calculated in quadrant B minus the angle that we got from our given information, and that tells us that angle C, this angle up here, is 94.72 degrees. Over here, we have 180 degrees minus the angle from quadrant 2 minus the angle from the original problem, and we have that it's 44.3 degrees. So angle C would be this little angle right here. All right, and then we calculate sine. So I'm going to do sine of A over 12 equals sine of C over C, because I'm trying to find the length of C. And I do the same thing in this triangle. And I wrote down rounded answer, but remember we're using like the whole angle that we have. And then isolate for C in each instance, and then you get C is approximately 34. So as we are doing the C, we're using the law of sines, we're writing down our ratio, we're entering into our calculator, we get a value for triangle 1 of 34.15, and angle C, it looks like 23.9, I'm guessing that might have been 0, but I'll double check on that. All right, so that's, if you're asked to write out your answers, this is what it should look like. You should see this triangle with everything that belongs in this triangle, and the second triangle with everything belongs in the second triangle. Because if you accidentally confuse this C with this B, now you've not completed the triangle correctly. So, you know, be real careful when you're working through your answers if you're asked to write that down. So I did need to clarify right here, it's 0.93 meters on both of those. But that's the case that always kind of gives people a little trouble. You want to be sure and check for that second case, that ambiguous case, and you want to be sure and make sure you get all of the things that you're calculated associated with the right triangle. Okay, so now we're going to move on to a different type of triangle. All right, guys, just 2 problems left to do, so hang in there. I know this is a little bit longer, but this case, there just is a little longer with that ambiguous case to explain. Okay, so now on number 2, we have our triangle. We're given A is 83 degrees 20 minutes, C is 54.6 degrees, and C is 18.1 feet. So what this is this is a way to break down a degree into smaller increments. So you can break it down into minutes, and then you could break a minute down into smaller increments, which are a second. So in this particular triangle, we have these 3 types of information. Notice this is written different than this, so our final answers will all need to be back in degrees and minutes. This one is in pure degrees. And so if you wanted to take that 0.6 and turn it into minutes, then we'll show you how to do that. So first off, let's lay out our triangle, because that's always the first thing we want to do. Lay out the triangle, determine what kind of angle it is. So this wasn't acute, so I just drew, this wasn't obtuse, excuse me, so I just drew an acute angle and I labeled my information. That meant what I'm missing is angle B, side A, and side B, and this is classified as an angle, side triangle. So that's good for us because that means there's only one possible solution, so we just need to find angle B and sides A and B to complete the triangle. So first off is that we want to talk about how to handle that 83 degrees 20 minutes. So we have 83 degrees and we have part of 1 more degree. We just don't have a complete degree. So in essence what that means is I have the 83 full degrees plus 20 out of 60. And the 60 is how many smaller units you can break a degree down into. So you can break 1 degree down into 60 minutes. You can break 1 minute down into 60 seconds. Okay, so if we take that 20 over 60 and divide that out, then that's what the full degree is. Okay, so maybe you would store that if you were needing that information for something else on the paper. So if you are completing side B, or angle B, excuse me, you take 180 minus the given angle either written like this or as I show you how to handle that in the calculator momentarily. And then we get angle B is approximately 42.00667. All right, so if we want to change that back to the smaller increments, so let me get that in my calculator. So I have it. So I would do 180. Let's get on this side where you can see it. There we go. Now you can see the calculator. 180 minus the given of 54.6 minus the given, and then I would do 83 plus 20 divided by 60, or you could simplify that fraction. and definitely type it in there correctly. And so that gives you the angle that we have. Now if I want to get this back into minutes, there's a menu on your calculator right above the apps button. If you can read that, it says angles. So we're going to use the angle menu. So we're going to do second, angle, and if you go down, there's your degree symbol, your second symbol, but right here is what I'm looking at. Choice 4, triangle means change. That's degrees, minutes, and seconds. So you press that and you can see it's taking the answer we had here and now it's going to convert it back, and we would get 42 degrees 4 minutes. And so that's how you would write your answer. So you have to pay attention to how it's given in the problem. If it's given with degrees and minutes in the problem, your answer needs to have degrees and minutes as well. All right, so then to find length A, I used angle A and I used angle C because we're given C and we can find A. So I rewrite my problem so it's ready to go in the calculator. And I'm actually this time going to enter it just like that using that same angle menu, which is second app. So I'm going to get my alpha y equals to get my fraction. I'm going to do 18.1 sine, and then I'm going to do 83, go to the angle menu and get the degree symbol. And then I'm going to type in 20, go to the angle menu and get the minute symbol. And then I'm going to close it. And then I'm going to go down to the bottom and I'm going to press in sine, and I'm just going to have 54.6 degrees, which we don't need the symbol for since it's all in degrees. And then I hit equals, and that gives me my answer, 22.06. And remember that it's length, so I don't have to convert anything. This is just what I have, and then I can do basically the same thing for B and calculate that. So I'm going to do angle B over B, and I'm going to do angle C over C, and so I have multiply these two, divide by this, so I have 18.1 sine 42, do the second apps to get to the angle menu, put in the degree, type in the 4, second app, get the minute symbol, all over 54.6, and then execute it to find here. So remember, when you're writing your answers for lengths, don't forget to put the units in there. And so if you had to write out your answers, you could write out these 3 things that you found as your answer. Okay, so that takes care of problem 2. The last one is an angle problem. Okay, so to find the area of an oblique triangle with no right angles, remember with the possibility of 3 acute angles or 2 angles that are acute and 1 that's obtuse, the angles still have to add up to be 180. So the formulas that we use are here. Notice we're using sines because we're in law of sines. We'll learn a different area formula next time that uses cosines. All right, so again, these 3 formulas look like you should have to memorize 3 different formulas, but if you look at the pattern, it'll help you to realize. If I have side A, side B, so I have 2 sides, but I don't have the angle that is associated with either one of those sides. So I multiply 1/2 AB, I multiply that together and take the sine of the angle that is the length I don't have. And this one I would multiply B and C and take the sine of the angle for the length that I don't have. And this one is A and C, and then I would take the sine of the angle for the length that I don't have. So that's how that pattern works. All right, so let's work through 3. So we're given to have a triangle ABC. We're given that angle A is 130 degrees, side A is 62 feet, side C is 20 feet. So we're going to draw the triangle and label the parts just like we've been doing on every other problem. So here's my given information, here's what I don't know, and then we're going to calculate the area. So you can see I have side A and I have side C, and then side B is the length I don't have, but I have that angle. All right, so technically I'm taking 1/2 side A times C sine B. So 1/2, 62 is side A, 20 is side C, and then sine of 130 degrees. So when I calculate that on my calculator, it came out to be 474.94755547, and we're going to go to 3 decimal places because that's the standard unless I tell you different. And then remember that all area is in square units. So because this was in feet, this unit measurement has to be in feet squared. and that takes care of the last of our law of sines. So practice, make sure you've got these down, because again, like I was saying, next time we are doing law of cosines, but there are some problems that you have to use the law of cosines on in the beginning, but that you can fairly quickly switch over to law of sines, which lets us do the ratio things that we've been doing and making it a little easier to calculate. Thanks, guys.